This is CCNA. I'm Ryan. We continue on with part 2 of troubleshooting enterprise networks. We're taking a look here at the way DHCP is set up. It tells us that router 1 and router 3 here are DHCP servers. And we're to find out if they're doing the job. So if we look at the PCs and look at the IP configuration, the default gateway and the IP address match the network that they're on. Then we can be pretty sure that they're good, but without even having to look at the router. Though technically the default gateway needs to match exactly the address there. And the only way we would know that is if we looked at the router configuration, or if we made sure and did a ping to see if it worked. But for right now, we're just going to take a look at the addresses. Here we've got 192.168.30.11 and 192.168.30.1. So those look like they're pretty good. Take a look at this guy. Okay, 192.168.40 and 192.168.30. So the default gateway is in a different network than the IP address. That won't work. So this PC3 has no way of getting, and if we look at that, it's set up for DHCP. So it's getting this from router 3. If we look at this one, 192.168.50 and 192.168.30, also no good. You can see how someone was maybe copying and pasting the configuration and they just didn't change the default gateway. So they did it right once and then the other two got bogus default gateways. So if we look at said router, just look at the running configuration. It's never a bad place to start. And we can see here that we've excluded some addresses so that we can assign some static IP addresses in the same network. And if we look at the configurations, there's the default router. So DHCP is doing what we told it to do, but it's not correct. So I just want to make sure to see here if it tells you make all necessary corrections. So this one doesn't actually give you the commands that you need to change, but should be pretty straightforward. In this one, we just do the default router and 192.168.40. It's nice that they match the network number to the VLAN number, but that's not necessary. So we change default router, and then we do VLAN 50, and we change the default router. And I'm using the up arrow because then I don't have to type it in again. And we do copy, run, start. Now we could wait for the DHCP settings to time out, but what they want us to do is, you know what? I wonder if we just switch between these two. It resets. Okay. So you can do it in the GUI. If I remember, if we go over here, we do IP config /renew that also works. That's PC3 again. We need a PC4. There you go. So now that's great. So we're up at 63%, and we're cooking right along. So can we ping from place to place? It's a good way of telling whether or not things are going right, and it looks like they are. You ping our default gateway. Yeah. Ping the default gateway. Yes. Okay. So we're looking pretty good. That's part 2. And well, rather than making it a super short video, I'll just go on to part 3. So verify the following requirements. So we have OSPF running between these routers. We want to make sure that it's running optimally. So like right now, we let's see if it'll get from here to here. No. Okay. So what can we get from here to here is a better question, because that's what we're going to look at first. Okay, right. So clearly we've got some issues with connectivity, but OSPF is giving us connectivity to this, well, or is, no, that's not a remote network. Okay, so maybe OSPF isn't doing what it needs to do, because that's directly connected. It could just be pinging that, so that's directly connected network. It's not a good test. All right, so we can get all the way across to this remote network. So this router has to be learning this network from this router. So router 1 is learning from router 3. So OSPF is up. It's doing stuff. I think there's some other things that are going up there that we need to fix. We can look at the routes on router 3, which is a good one to start with since it's got the most networks on it. Go to show IP route. When we do show IP route, we're looking at IPv4. We're just looking at the OSPF routes here. Do we see all the networks, I guess is what they're trying to tell us. And 10 and 20. Or, I mean, we're only learning the remote networks this way, so there's 10, 20, and this is going to be the internet, so that's we access that through a default route. Which, if we look, show IP route, we're not getting a default route. So for now, we're getting what we need OSPF wise, but we need to go back to router 2. It even tells us what to do. We need to distribute the default route. Oh, silly me. Distribute the default route from OSPF. So if we do show IP route, we have a default route. And I bet if we did, we have a static default route out gigabit Ethernet 00 to the internet, which is exactly the way that we would want to configure a default route. But we also want everybody else to learn it through OSPF. So if we do comp T and we do router OSPF 1, we do default information originate. Now, and we should probably, it doesn't doesn't grade us on this, but we should do the copy run start. Just stay in practice for doing that. We go back to router 3. Good. We now have a default route. And this guy will have a default route too. So if we try to do that ping thing again, it'll work now. Yeah, okay. So now we have a default route, but we're going to find out. Oh, actually. All right. Well, that didn't give us a lot of percentage. It gave us 5% for doing that. I guess it was only one command. So, so we got the default route. Now we can get outside of our locally learned networks, which is great. IPv6. So router 2 to the outside hosts. The little instant PDU doesn't automatically give us IPv6, so we'll just type in a ping, which is probably better for instructional purposes anyways. Ping 71 : and we're doing this IP address right here, the outside host, just like it tells us to, DB8 : B : 64, and then a double colon and 10. And that's successful. So our default route's getting us there and back. That's a good sign. Where is it? There you go. The outside host. We're going to go from router 2 to PC 4. Okay. So fortunately, all these PC 4 ends in 5010. 5010. So fortunately, we can see the up arrow. Not sure. No, it likes it. It likes it. So we can ping from here to here. And we go from router 3 to the outside host. And we're going to find that we don't have a default gateway. Okay. We do show IPv6 route. Remember, IPv6 and IPv4 are separate protocols, and they have separate routing tables. And well, we can do fancy things to get them to interoperate, but also, yeah, right now we do have an OSPF route, which is why we can ping our internal networks, but this guy shouldn't be able to get to there. And they want us to go from router 3. Yeah, that's where they wanted us to go. Okay, so router 3 to the outside host, ping 2001 DB8 B 64. 2 colons and a 10. Remember, the 2 colons are like taking the place of a bunch of zeros, and it makes it a lot easier to type. So we got the IP address correct, but it's timing out, and we know why. We don't have a default route, so we need to go back to router 2 and enter IPv6 configuration mode. Remember the number at the end. It doesn't have to match between routers, but you need to make sure to use the same number every time. So it's just better to make it the same. On the same router, you need to use the same number every time. So in IPv6, there's fewer commands in the router configuration mode. You do a lot of the configuration on the interface. Try this. And you can see that there's a lot of the IPv6 configuration at IPv6 OSPF. So we're just saying that this interface is in area 1 and have it participate in OSPF right on the interface. So that's the difference with IPv6 and IPv4. And now if we go back, do that ping again. This is router 2 though. So we go back and do, oops, it's right there. And do the ping. Successful because now we've got a default rate. So it says it's a external OSPF route, and this looks like a funny emoji, but the double colon means that the whole address is 0, and then the /0 means the subnet mask is 0. So this is the same thing as the quad 0 in IPv4, which is the default route. And it tells you what network it's sending it to. In fact, it gives you fully resolved. So it tells you the network and the interface. And we're at 74%. And we'll call this one a wrap.